Good morning, good afternoon, good evening. Welcome to Traceable AI's webinar on the evolution of the OWASP API Top 10 Vulnerabilities. My name's John Jeremiah, and I'm excited to be your host for today's webinar. Today, we're going to cover a handful of things, an overview of the OWASP API Top 10 and how it's changing, techniques for identifying and exploiting these vulnerabilities, and best practices and ideas about how to mitigate against and protect your APIs from these vulnerabilities, along with perhaps some examples of real-world attacks and their impact. I'm really excited today to be with Inon Shkedy, who is the project leader, one of the project leaders for the OWASP API Top 10 project. He's a recognized expert in API security, and he's our leader of the Traceable Security Research Team. Traceable AI is a leader in API security. We're committed to providing our customers and the market with the best-in-class API security solutions to help you protect your digital assets. We really hope that today's webinar will provide you with valuable insights into the evolution of OWASP API Top 10 and help you to better protect your organization. So let's get started. I hope you enjoy today's webinar, the evolution of the OWASP API Top 10 Vulnerabilities. Inon, over to you.
Thank you so much for the intro, and thank you guys for joining us. Today we're going to talk about the evolution of the OWASP API Top 10. Before we start, I just wanted to give you a quick introduction about myself. My name is Inon Shkedy. I'm the head of security research at Traceable. I got about 10 years of experience with application security, and I tested many applications during this time. And I grew up with APIs. What does it mean? Basically, I started my career back in Israel. I used to be part of the red team of the Israeli army. I used to test many systems in the field of government, military, and financial, and I got exposed to very traditional concepts like Java, ASP.NET, SAP, and they're based on multi-page applications, on-prem environment, waterfalls, and those applications I used to test during this time, they didn't have many APIs, mostly for B2B communication. After 5 years serving in the Israeli army, I decided to buy a one-way ticket and go to live in the Silicon Valley in California. And in the last 5 years, I've been exposed to new types of technologies. Working with startups and tier companies, I started seeing things like Ruby on Rails, Node.js, Elixir, and very modern concepts in application development. Single-page applications, cloud environments, CI/CD, and the most important part is that all of them are heavily based on APIs. So today's APIs is no longer just a niche component for B2B communications, it's the backbone of the application. After seeing all these changes, it made me realize that I can't find the same vulnerabilities I used to find back in Israel. I had to change my mindset and the way that I test and hack applications in order to stay relevant in the industry. And this is what led me to be so excited about API security. So the agenda of the webinar today is just to talk about a little bit about the product background and then to see some new trends in application and API security and what to expect from the new list. So just for those of you who don't know, OWASP is a non-profit organization that the goal of this organization is to educate developers and pen testers, engineers in general, about application security. Some of the most well-known OWASP projects, it's Mod Security or CRS, which is the open source WAF. You can find Juice Shop, which is a vulnerable application that can help you to practice application security as a pen tester or developer. You can find Zap, which is an open source DAST tool that allows you to scan your applications, and the OWASP Top 10. The OWASP Top 10 is a list that is published every few years. The interval is not strict. Sometimes it's 3, 4, 5 years. But basically, the goal of the list is to describe the top 10 threats for web applications. So the problem as a security engineer or as a developer, you have so many vulnerabilities. It's almost impossible to navigate this endless sea of security issues. So the goal of the OWASP Top 10 is to give you some focus and to tell you, okay, maybe you're not going to cover all the application security issues, but if we invest time understanding and testing for the OWASP Top 10, you should get a pretty decent coverage from many types of application security attacks. In 2019, I started with Erezi alone from Checkmarks, a new project of OWASP API. Basically, from the understanding that APIs are very different than traditional applications, and they also expose different types of vulnerabilities, we started this project basically to help developers understand what are the top 10 threats for APIs. We published the first list in 2019. We got a lot of traction from different organizations like Gartner, a lot of press release about the project. But what we realized that things change since 2019, and in the last 4 years, there are many new trends in application security, and the way that hackers exploit APIs, that there need to be some change. And this is why we came up with a new version of the OWASP API Top 10, and we recently released the release candidate. I just want to talk a little bit about the creation process, basically to help you to understand how we even come up with those lists. The first step is to gather information. We extracted data from bug bounty reports, from platforms like HackerOne and BugCrowd to see what is more common among APIs. We reviewed a lot of public breaches, and we also interviewed many thought leaders in the industry, or just even people who perform pen tests for APIs. Based on this feedback, based on this information, we conducted the first draft of the release candidate. This draft was reviewed by initial set of reviewers, thought leaders in the industry, people from different vendors and companies, and after getting the feedback, we adjusted the list based on their feedback, and we recently published the release candidate a few weeks ago. And now we're in the process of gathering feedback from the community and adapt the list based on the feedback. So we're gonna publish the final list in a few weeks probably. So I just want to mention that what I'm gonna talk about, the current version, it's the release candidate. It might be changed a little bit, but still we can see the new trends using this release candidate. Before talking about API security and modern application security, I want to spend some time just talking about, what is the difference between a traditional applications and a modern application. So an example for traditional applications would be, like Yahoo homepage of 10 years ago, okay? Everything was on the same in different pages. Every time you click on a link, you would open a new tab. And a good example for a modern application is the Google Drive that you might use, or Google Docs, which is a single page application. So in order to understand application security, we need to understand application development. And in order to understand new trends in application security, we need to understand what changed in the field of application development. So let's talk about some of the patterns between the client, the web server, and the database, and compare them traditional versus modern. First of all, back in the day, on the top side of the slide, you can see how the patterns used to look like when it comes to traditional applications. The clients didn't really know exactly what they need. They would ask for some abstract pages, for example, the home.jsp, and then the web server would process this request, fetch data from the database in order to create this visual page and send it back to the client. So this process of getting the data and creating a visual page, it's called the rendering process. And back in the day, it used to happen on the backend. Then the web server would send back to the client this complete, very easy to digest visual page in the format of HTML. And basically what the browser used to do is just to present to you the HTML, which is much more simple than what browsers can do today. The reason for that is that back in the day, the hardware that people used to use was much less powerful. So browsers used to be a bit more simple, a bit more dumb. And this is why they just got this easy to digest HTML and present it to you as the user. Today, in modern applications that are based on APIs, things look very differently. First of all, the clients know much better what they want. They wouldn't ask for like a full HTML page, you know? It doesn't make sense in most applications. They would ask for specific pieces of information. For example, they would ask for the last 10 notification for the user. They would ask for the like top 5 like leaders from the leaderboard, or for like the news articles from the last 2 hours. So they send more parameters, they send more API calls to the server in order to fetch data of what they want to consume. And then the API in some way is used as a proxy between the client and the database, because it just fetches data from the database, and also you have more types of database on top of like the traditional SQL. You can find NoSQL, Elastic, and so on. And the API, instead of like the web server, which is the API, instead of just taking this information and build like a beautiful HTML page, it doesn't do it anymore. It just returns you raw data in the format of JSON so the client can consume it. And then it's the responsibility of the client to create a visual page. The rendering process moved from the server to the client side, which is a very important change that also impacts application security. So today clients are much more smart. On top of that, you can find more types of clients. On top of like, the traditional browsers, you can find IoT devices, mobile, and even other developers that use your API to develop their own applications. And also the less abstraction layers. It's much easier to look at the traffic between the client, the API, and the server, and to understand the implementation on the backend. So many things that back in the day used to be concealed or unknown for the client, it's much easier to understand how things work behind the scenes if you just take a look at the traffic. The reason why it happens, it's much easier as a developer to use APIs. Like if I'm a front-end engineer of a company, I can just take a look at the documentation of the API and understand how the data looks like, understand how the backend looks like. And it makes it easier for me to consume the data and to develop my own application independently from the backend developers. At the same time, it also makes it much easier for attackers to understand how things work behind the scenes in order to exploit the API. So when it comes to modern application security, there are good news and bad news. I want to talk about let's start with the good news to be optimistic. Some of the traditional application security issues have been solved, or like mostly been solved in the last few years. Things like SQL injection are much less common today because of the use of ORM environments. You can still write code that is vulnerable to SQL injection. If you use ORM, it's just much more difficult to do it. It's much less intuitive to write this vulnerable code as opposed to native SQL back in the days. And I would tell you a secret. The reason why developers choose to use ORMs is not because it's more secure, just because it's more simple to use them. Things like cross-site scripting, it still exists, cross-site scripting, but today it's not a responsibility of the server, of the API to protect against cross-site scripting, because the API literally returns you raw data in the format of JSON and not HTML. So if it doesn't return you HTML, it cannot protect you against cross-site scripting. It's the responsibility of the clients that consume the data to protect against cross-site scripting today. And if we talk about XXC, which is a vulnerability in the parsing process of XML, today it doesn't really happen because developers use JSONs instead of XML. So if you don't use XMLs, you're not vulnerable to XXC. But there are also many bad news. First of all, the attack surface when it comes to APIs is much larger. If you talk to every pen tester, every security engineer, they will tell you the more parameters you can send to the backend, the larger the attack surface. And the nature of REST APIs or GraphQL APIs, by nature, they receive more parameters. They expose more entry points. And this is why attackers would have more places to try to inject something, to manipulate the input, and so on. On top of that, APIs are oversharing. There are more endpoints, as we talked about, but also APIs tend to expose too much information by design. So because APIs are very generic, and one endpoint can be consumed by different types of clients. For example, one endpoint can be consumed by the mobile application, by the browser, and also by different types of users. For example, in Uber, you might have riders and you might have drivers, and they might both access the same API endpoint to consume data. So what happens many times on the backend, the developers just tell themselves, okay, I need to create a generic endpoint, so I'm just going to expose as much data as I can to save time, and then the developers on the front end going to figure out what they need to use, which is a very bad approach because many times it leads to the API endpoint to expose too much information and even information that shouldn't be exposed to this type of user. So this is why APIs are more oversharing. And then the last point, APIs are more predictable. The REST standard encourages developers to write APIs in a very generic way, which is easier to consume, but also much easier to guess as a pen tester. And it's also easier to exploit because you understand better how the API looks like. For the 2023 list, which we just released the release candidate, we actually added a new leader to the project. His name is Paulo Silva, and he used to be a main collaborator in the previous version, but now he's one of the leaders. So this is the release candidate. You can see many changes. I want to talk about some of them. First of all, we added new items. We decided to combine excessive data exposure and mass assignment under one new category of authorization. We added server-side request forgery, which is a very common vulnerability in modern applications. We decided that it's time to address the risk of bots or automated threats, and this is why we created a new category for them. We added a new category of unrestricted risk of consumption and also of unsafe consumption of APIs. So it's basically the awareness that you need to protect not only against what you consume from clients, but also what you consume from other APIs. We decided to remove a few items from the list. The first one is injection. The second one is insufficient logging monitoring, and also it combines two different items of mass assignment and excessive data exposure in order to free up some space and bring up new vulnerabilities. The item that were expanded is improper asset management and broken user authentication. It now is just broken authentication, is a bit more generic. Before jumping into talking about each one of the new categories, I want to talk in a bit more high level. I think there is a consensus among security engineers and pen testers that the biggest risk of APIs today is authorization. And this is something that I've been saying for a long time, that almost every API breach that we see on the news is something related to authorization. And I've been questioning myself, what's the reason it's so difficult to implement a decent authorization mechanisms in APIs? And I don't know what is the answer, but I have some assumptions, and I think the main reasons why the authorization challenge is so big is because two reasons. First of all, you have some security mechanisms that are very well defined. They're very centralized. If we talk about authentication, for example, or just authentication, it's something that can be done in one place in the code or a few places in the code. But you might have just one team that should care about authentication, and then the rest of the company shouldn't worry about it. If you talk about authorization, it's very different. It's a very decentralized mechanism. Every developer that writes code in your company should care about authorization, because authorization checks should be done in many, many, many places in the code itself. We talk about object and object property level. And when it comes to the function level, it also can be done in the code, but also sometimes in the configuration or the API gateway. So it's become a very shared responsibility of security. It's not just one place, it's very decentralized, and this is why many times developers tend to make mistakes. Because if you have 1,000 developers work for the company and they write code every day, at some point someone is going to forget to perform the authorization checks they should perform. The second reason is that in modern applications, you have very complex structures of users and roles. So if you take, for example, some healthcare provider app, you might have different types of user, patients, care providers, and admins. Then you would have some weird cases that you have the user Hugo, who has 2 sub-users. So I might be able to create a sub account for my mom. And then the policy that defines authorization becomes very complex, because by design, some users should have access to other users, right? So it makes it more difficult to understand what are the limits of authorization. And then you might have cases that you have one user, like Jack, that belongs to 2 different groups, who is a care provider, but also an admin. So that's just defining the idea behind the authorization. Before even going into code and to write the authorization itself, it's kind of like complex to define how the authorization should look like in a high level. We have 3 types of authorization issues, and I want to talk about each one of them. And for this thing, I'm gonna give an example, the Airbnb API. Okay, not because I found vulnerabilities on the Airbnb API, just because I think it's a good example for modern application. So if you book a place on Airbnb, there is a pretty straightforward process that you need to ask the host to reserve the place, and then the host has to accept your reservation. You can't just book without the host accepting the reservation. So as part of this process, the host has to access the API endpoint. I mean, it happens behind the scenes. He just needs to click one button on the dashboard, but behind the scenes, there is an API call to post/API/accept reservation. Those endpoints should be accessible only by hosts, right? Because I'm as a regular guest, I shouldn't be able to accept reservations. What happens many times that the developers don't make sure, they don't check that the user who is trying to call the API endpoint is actually from the right group or the right role. And this is where a broken function level authorization, which is BAFLA, happens. And if a regular user can access an endpoint that shouldn't be accessed by this type of user, this is a BAFLA. Many times you can see admin functions that are exposed to normal users, and this is dangerous. So let's say that even if the developer implemented the right function level authorization checks, the next level is broken object level authorization. I'm a host, I'm trying to access the endpoint, I'm from the right group, but then the API endpoint might be vulnerable to BOLA. BOLA is the #1 vulnerability, and personally, every API that I tested in my life, I found at least one BOLA. It's very difficult to protect against BOLA. Just to a simple example what BOLA can be, I have the accept reservation endpoint, and then you have the ID of the reservation. What is this ID? See, like the ID equals 919. What's the reason that the API needs to know about this ID? So the thing is, as an Airbnb host, you might have many different reservations at the same time, because different users are asking reservations at the same time. So if you want to accept one reservation, you need to mention which reservation you want to accept. And this is where the ID is coming into the picture, which is basically a numeric value or a GUID that represents the object of the reservation in the backend. So in a BOLA vulnerability, what happens is that the user is trying to access an object that doesn't belong to that. So I'm just changing the ID from 919 to 918. And then I might be able to update a reservation that doesn't belong to me. It belongs to a different host, which is bad, because the developers might not validate that this ID belongs to me. And BOLA can lead to many different things. In this case, I can just accept reservation of someone else, but many times it can lead to a full account takeover, or being exposed to information that doesn't belong to you. The highest level of authorization, even if the developers performed authorization checks for the function and the object level, you also need to make sure that the user can access the property of the object that they want to access. So let's talk about the reservation object, right? In the Airbnb platform, it might have different properties. Some of them should be accessed or changed directly by the host. For example, the address, of the reservation, but some of them not. Some of them should be set internally, like the price of the stay. So basically, the client, the guest, made a reservation and they agreed to pay $100 for one night, for example. But I'm the host. I want to make more money, so I might be able to exploit this type of authorization of the object property level and add it the total stay price. So if the developers don't make sure that I have access to update the object property, which is the total stay price, the API would be vulnerable to a broken object property level authorization. And then I basically would charge the guest much more than what they are supposed to pay. Another category that we added is unrestricted resource consumption, which is kind of a category that is related to rate limiting, but is more expanded. If an attacker exploits this type of category, they might lead to denial of service or to make the API consume too many resources that can really bring up the cost prices of the app. Another interesting category that we decided to add is the basically lack of automated threat protection, which is talking about bots. What we are seeing in the last years, that bots are becoming more and more common and they are targeting APIs. Some of the challenges around bots is that, first of all, they're becoming more profitable. We can see on the darknet that attackers are becoming more and more creative on how to make profit out of bots. They're becoming smarter and more human thanks to AI and machine learning. So, for example, if you have a bot that writes fake reviews for like Amazon, for example, those reviews might need to be validated by a team on Amazon. And if all the reviews contain the same text, or it sounds like that a human haven't written this review, they might just delete the reviews. But now we can see that the operators of botnets, they use, for example, ChatGPT in order to generate text that sounds like a human wrote it. So it's very challenging to know who is a bot and who is not a bot, thanks to AI and machine learning. And I think the biggest challenge of like protecting us against bots is just the fact that the protection cannot be generic. So it really depends on the business need, and some areas of the app might be more dangerous or less dangerous based on the business needs and the industry. Do you know what is common among sneakers, PS5, and COVID masks? Is that all of them have been a target for scalping bots. Scalping bots is a pretty interesting concept. Basically, if you have a high demand product like PS5 of Sony, there are bots that are going to try to buy all the stock at once the Sony allows you to buy them, and then resell them for a much higher price. This is something that many companies, all the big e-commerce companies, have been struggling with, to limit, like basically not to let bots buy all the items from like a high demand product and then resell it for a much higher price. This is a real threat, especially in the e-commerce field. I would say that there are two different families of patterns of bots. The first one, bots that are trying to gain advantage over normal users. And the second one is bots that are trying to access the API in a very excessive way to cause some malicious impact. So the first one, if you want to gain advantage over legit users, you have the speed advantage. For example, I might be able to buy the product much faster than a normal person. So if someone is trying to buy PS5 and is just like a human like me, it would take me a few seconds to click on the button to complete the transaction, to put my credit card. So it's a matter of like at least 5-10 seconds to complete the transaction. But the bots are much more fast because it's just a script. So they might be able to buy it in like half a second or even less. And then you also have the quantity advantage. I can vote many times. If I'm like a regular user and I need to vote on something, I might be able to vote only once, or like it would take me some time to create like different votes. But bots, the advantage is that they can just come from different IP addresses in a kind of distributed way and vote many times and then win something or something like that. And they also can post many comments. Things that are more related to excessive consumption, the fact that bots can access the APIs many times, in a much more efficient way than a human, makes it dangerous. For example, if I had to perform credential stuffing, which is just guessing the password of someone as just a normal user, it would take me a lot of time. But bots can do it much faster, in a much more automated way, and then they can hack passwords of other users, which is credential stuffing. Protecting against bots is challenging, and the reality is that there is no one good solution on how to do it. And there is no one bulletproof way to protect against bots. It really depends on the business needs, how much effort you want to invest in the process, and who are your attackers. If you're trying to protect against script kiddies, it would be easier than protecting against someone who is very experienced in writing bots. So the different layers you could implement in order to protect against bots are, first of all, you can restrict the IPs that are accessing your system. So, for example, if you are like a retail website and you sell something, but you can use this service only from the US, you might want to block all the other countries from accessing your API. And if you don't want to completely block the access, you might want to block them from accessing the endpoint of completing the purchase or the more sensitive endpoints like login. Then on top of that, you have rate limiting. Basically, you can't access the login endpoint more than 5 times in 1 minute. And if you do, this IP address should be blocked. Those two first layers can be bypassed pretty simply. For example, using a proxy, or just like sending the attack from different locations in the world. But it's not about completely stopping the bot. It's just to make the attacker life harder. On top of that, you have human detection, things like CAPTCHA. If you are trying to buy a new product, you have to to write some text that it's more difficult for bots to be able to answer. And then the top layer is just to analyze traffic for abnormal activity. So if you see that during a normal session, a user would log in, look for different products, and then perform checkout, the 1, 2, 3, this is okay. But what happens if one user logs in and then performs checkouts 5 times in a row? This is kind of suspicious, and this is one way to identify bots. We also decided to add SSRF, server-side request forgery, to the list, which is a vulnerability that helps you to kind of manipulate the server to perform actions on your behalf. So if you have some type of a social network API, for example, it allows you to upload a profile picture. And you have 2 options. You can upload the picture from your own device, or you can put the URL of the picture. What happens is that once you put the URL, the API would access the URL and try to download the photo. But what happens if I'm malicious and instead of putting a URL of a real photo, I would just put a URL of a very large file. I might be able to make the API work very hard in order to fetch this resource, and it could cause denial of service. So this is one example of what we can do with SSRF. SSRF, one of the reasons why SSRF becoming more common in APIs, it's because of the use of webhooks. And just like webhooks is some type of SSRF by design, it's also becoming more dangerous in modern applications because you have many services that expose management consoles over APIs by design, and it makes the exploitation process of SSRF easier. Inventory blind spots, it's a different vulnerability I want to talk about. We decided to expand improper assets management and to include more categories under this umbrella. So I'm going to talk about 4 different ways that you can have inventory blind spots. The first one is that you have an API, for example, the user's API of Airbnb. Then you have different endpoints that this API exposes. You have the payment, the post review, the search, and the old export user data. So the thing is that the first 3 endpoints have documentation. The developer took time and wrote documentation for those endpoints, which is good. But then the last one, the old export user data, is not documented. And you, like, developers that don't really know it exists. And you can't really protect what you don't know. And this is why it's dangerous. Other type of inventory blind spot would be that you have different APIs or different microservices like that people are aware of. But then you have, many times I would go to a company to perform like some type of security assessment, and then I would see something like qa3.airbnb.com/backup API. And I would go to the DevOps team and ask them, what is the reason that you have this microservice or this API exposed to the internet? What is the goal? And then like, they just tell me, oh, we actually don't know. There is like a DevOps member that left us a few years ago, and we see some traffic to this API. We are not sure what is the reason, but we are just too scared to remove it because we don't want to harm the business. And it's even more dangerous because this API might expose many endpoints. And the thing is that with those type of APIs, they tend to be a target for attackers because many times they don't implement the right security mechanisms. The other type of blind spot is that you might have some internal microservices that are exposed directly to the internet. So what happens during a normal flow? A client would want to access a specific API that is running on a specific microservice, and it would go through the API gateway. And in the API gateway, you might add some layers of security, like authentication or like rate limiting. But then a developer decided to expose one microservice directly to the intranet that allows direct access, which is very dangerous because you might be able to bypass those security mechanisms and even access functions and endpoints that are only in general. On top of that, you have what you share with other partners. So API is not just about, especially in modern applications, it's not just about the data that you expose to the clients, but it's also the data that you share with other third-party APIs or other partners. So I give an example again with Airbnb. I have nothing personal against Airbnb. I haven't found any vulnerability, but it's just a good way to talk about modern applications. So Airbnb allows you to use other platforms as a host to improve your experience as an Airbnb host. And those apps needs to be approved by Airbnb. So, for example, Guesty is one of them. And if you decide to use Guesty as a host, there would be some communication between the Airbnb API and the Guesty API to feed data and to exchange data with each other. For example, it would be done using an API of B2B/sync user data, which is fine because you gave the approval to share some data with Guesty. But many times companies don't have the visibility on which data is being shared between one company to another or between one API to an external API that is not living in your environment. And this is where things become dangerous. For example, maybe the tax microservice shares too much information with Guesty, like the payment details that Guesty shouldn't be able to access, and it's kind of a violation of also the policies of the company. And the user didn't give an approval to share this information with Guesty. And if something bad, some like breach happens on the Guesty side, the users might the information might get exposed, and more information than what they're supposed to access. So basically, the main point here is that as a company, you need to have visibility into those things. What APIs you expose to the clients, what type of data you share with other partners, and so on. The last vulnerability that we introduced to the list that I want to talk about is unsafe consumption of APIs. So let's say that you have some application that shows you stats about your Twitter account. There are many APIs like that. You can just, if you want to know what are the top tweets that you have tweeted in the last 5 years, you can use that. And so if you develop this kind of like additional app on top of Twitter, you would have two different data flows. First of all, if you want to create a user on the Twitter stats app, you would have like an endpoint of create user, right? But so the thing, many times developers, they put more effort on security when it comes to input that comes from the client itself. They're saying, okay, client is evil. I'm going to like be very careful. If I'm going to process like some string, I'm going to make sure it's not vulnerable to SQL injection or something like that. And they would just block any type of attack from the client. But what we are seeing is that developers tend to be much less careful when they consume data from other endpoints, from other APIs. For example, if they want to get the top users from Twitter, they're gonna trust the Twitter API to return them like safe data, which is bad, because Twitter API, you can't trust an external API. It's not something that is developed by your team. And many times we can see the developer forgets to implement the right security mechanisms when they consume output of external APIs or third-party APIs like the Twitter API. This is where you might be able to pass through the security mechanisms and be able to manipulate the input in order, or in this case, the output, to cause things like SQL injection or other types of attacks. I don't think we have time for that. Another question that was brought up is like about new protocols. We decided we have seen many like breaches also when it comes not just to REST API, but also GraphQL and gRPC and WebSockets. The way that we decided to handle those new protocols is not by creating a new category for these protocols, just to involve them in the current list. For example, in security misconfiguration, we have examples for GraphQL, and also for in many type of vulnerabilities. Like for example, authorization problems are not only for REST APIs; they also exist in GraphQL, and they are pretty similar. We just provided more examples to show you how those issues look in different protocols. The last one thing I want to ask from you guys is to contribute to the list and to help us to improve it. Right now, we published the release candidate, and we would love to hear your feedback. So this is the end of the session. I hope you guys enjoyed. And if you have any questions, you're welcome to ping me on LinkedIn or Twitter, and I'll be happy to talk about API security with you. Thank you.